Hello everyone, thanks for coming. Today I want to talk to you about functional programming principles. Okay, uh, the way I structure this talk, I'm going to talk about just quickly a little bit about my introduction. The second part is what is the definition and the core concept of functional programming, and then the comparison between the imperative versus functional. And the last one, I will explain to you about the functional programming characteristics. Basically, the goals of this talk shall give you basic understanding of functional programming concepts. Okay, what's up? My name is Alvin. I'm a software engineer. Mostly I'm using JavaScript, Python, and Elixir for the last several years. I'm very interested about functional programming, AI, and machine learning. Okay, what is functional programming? Have you heard of functional programming before or already used? Okay, maybe I give you an example and overview from Wikipedia. What is functional programming? They say functional programming is a programming paradigm where programs are constructed by applying and composing functions. Okay, by applying and composing functions. Basically, functional programming is just a concept and programming paradigm where in the implementation you prioritize functions. Okay. Um, Functional programming does not depend of any particular programming language. You can use it in any programming language, but there are some programming language ready to use to functional approach like Elixir, Pascal, Clojure, Iris, and Script. Okay. Before we dive deep about functional programming, we need to know about function composition concept. Okay, what is function composition? Function composition is the way you combining two or more functions together, and the output of that function, one of functions, um, become the uh, input of the next functions. Okay. Um, to be more clear, I'll give you an example. Um, the implementation of function composition in JavaScript. Okay. Um, just in this case, I'll give you just simple case. Okay. Um, maybe we can put some arithmetic operation. So first, I will create just function will um, given some input x, and then the operation is x plus 1. Okay, and the second part is double function will multiply by 2. Okay. Basically, function composition it's similar like mathematical notation, where f dot g dot x. This means in programming perspective, you can say f dot g dot x like f apply g function, and g function take the x input. So we can get the conclusion for this formula in the real example. Okay, so if we combining two operations here, maybe I will call it double function first, and the input of double function is a add one function. So okay, so I will give input x is 2, okay, and at 1 the input is 2, okay. So we can see at line 16 double function um, take the take the at one parameter, take the at one function as a input, okay. So this is a function composition, okay. You combine two or more functions together, okay. So the at with if we break down the process here, first double function, okay. We first we evaluated the double function first, okay, and then double function first need to get the output of at one function. So we did not know about what's the input um what's the input value of double, because we have evaluated at one function. So we need to evaluate it okay. At one function, get the x x is 2, so 2 plus 1 becomes 3, okay. After we get the output of at one function, so we can evaluate it double function. So the input of double function is 3, and then the output of double function is 3 multiplied 2, and finally the output is 6, okay. I hope you understand about this concept, because function composition is the important and the main concept in programming, especially in functional programming. Okay, I will go to the next section. This is the comparison between imperative versus function. Okay, as you can see, all these codes are valid, but has a different style and has a different approach. For the imperative style, you um, need to create several steps. First, you need to create for loop to iterate the Ri, and then you need to store it, the value of sum from the each iteration from the for loop. Okay, and after the for loop finish, you can get the final result of sum. Okay, but the functional approach, you just use the reduce functions, which is this function handle the accumulation and the iteration as a default, and will return and produce the new outputs. Okay, you can see the output is similar. Okay, but if we look it again, the imperative way, we can look at this. We need to think what steps must be taken to achieve the desired goal. Okay, you need to create step first, like create for loop iteration, and we need to store to another variable. Okay, and at the line 6 you can see in the imperative way we need to explicitly change the value. Okay, while the functional approach, you don't need to explicitly update the original value or create a new value. Okay, you just use a simple functions, and you need to think differently when the functional approach when you're using the functional approach. You need to think by terms of thinking using function and expression. Okay, so in this case, the root function will accumulate the all value of numbers plus 1 plus 2, 2 plus 3, and so on. Okay, this is what Uncle Martin said about function. You need to think differently when creating a new function in the functional programming approach. Okay. Function, they must be very small, do one thing only, or SRP, must have few arguments, should not have side effects, and should avoid fake arguments. Okay. These requirements, or what Uncle Martin says, has a relation with the next sections about functional programming characteristics. Okay. You need to know about functional programming characteristics. Okay. First, we have first class function, immutability, period function, and higher order function. Okay. First class function in the functional programming you can call as a first class citizen. This means you can use everything you always using function, and you can define anywhere, and you can use the function passed as arguments or return from other functions. Okay, and the second part is immutability. You may seems it looks familiar. Yes, this is a JavaScript code where there are some variables such as cons and left. Okay, cons in the JavaScript, this means the variable is immutable or read only. Okay, and the let variable is mutable. You can change this value. Okay, basically immutability is when you create some variable, you will not be able to change the value. Okay, instead of you change the existing source or the original value, you must create a new value by copying the original ones. It looks similar like .map function in JavaScript, where when you define numbers .map, like in the functional example, that will produce a new output, but not change the original ones, the numbers value. Okay. Okay, next is build functions. Function is considered pure where has two conditions. First, deterministic, and then no side effects. Deterministic, it means when you give an same input, okay, then the output will return the same value. Okay, maybe you can look at this example. Some function has two parameters, a and b, and we call it twice. Okay, we call twice sum with the input 2 and 3, and the outputs always same. In the line 5, at the line 5, you can see output is 5, and the last one output is 5 again. Okay, and the next is no set effects. This means uh, the function that's not uh, change the external state. Okay, external state, it means like um, change the variable, change the value outside from function. Okay, outside of this function. Okay, be like some function. Okay, at line 3, the operation just do some plus operation or plus b. Okay, not change the external state. And when the function change the argument value, maybe like when some variable, some argument has a default value at the b equal 2 maybe. Okay, um when function is considered pure, that will not change the value of arguments. Okay, and the last one, when the function is not interaction with IO floats. Okay. This is an example of impure functions, where this function not deterministic and then not and have set effects. Okay, as you can see, deterministic, when we call this function twice, the output is different, but the input is same. This is because this happens because at line 12, as you can see, there are some process modifying the external states, which is value variable. Okay, and the last one is higher order function. Okay, higher order function, it's similar like function composition concept and first class functions, where everything we evaluate and um, do some operation using function. Okay, as we can see at line 7, numbers.map, we create some new function. It's called double. So at this operation, we just call the double function um, without give a parenthesis. Okay, because the map function will evaluate this function as a default. Because if you look at the JavaScript documentation, .NET has one parameter, which is the callback function. So this is the applying for this mean like callback function, but in other place. Okay, that's a concept of higher order functions, where you using function as a parameter, as a return from other function and other place. Okay, yep. If you um, implement this functional programming approach, you will get advantage like modularity, testability, scalability, and availability. Yep. Thanks. That's all for me. I think if you want to look at the game about this presentation, you can check at speakerdeck.com, Natserat. And if you want to follow me, you can follow me on Medium or github.com at Natserat. Okay, thanks. I hope you understand what's the functional programming concept, and I hope this is useful. And if you have any question, feel free to ask me at Telegram at Natserat. Thank you guys.